Good morning, everybody. We'll begin today's session. The first question. The image is a ceramic tile of dimension 20 by 20 centimeters. How many distinct patterns can you create by using two such ceramic tiles in a rectangular patch of 40 by 20 centimeter on a wall? What you are given on the left is a patch of 40 by 20 centimeter on a wall, and this is one single ceramic tile, which is of one particular pattern. We have to identify how many distinct patterns can be made on the patch using this tile. Okay, two such ceramic tiles. Now we have a tile, and if the tile can be rotated 4 times to create these four distinct patterns. 1, 2, 3, and 4. Okay, these are the 4 distinct patterns. So I'm talking about these patterns, all right? These are the 4 distinct patterns that can be created using the tiles. So if I stick to one pattern, say this one, 1, 1, this is 1, 2, 1, 3, 1, 4, and then I again take the second pattern, which is this one here, keep that stagnant and then repeat that same process. I'll get a 4 by 4 distinct patterns, which is 16 distinct patterns in total. Okay. Also, if mathematically, if you see one tile can, if you rotate it, because of the way it is colored, if you rotate it, you can get 4 distinct patterns and you have 2 such tiles. So 4 possibilities in one tile, 4 possibilities in another tile. That's where also 4 possibilities here multiplied by 4 possibilities here also results in 16. So mathematically also we get 16 here. Okay, or if you are looking for the pattern that gets created, these are the distinct patterns that it can form. Okay, we'll now move to the next one. A cube is created by stacking 27 smaller cubes as shown in the figure. A plane going through vertices A, B, C cuts the cube as shown in the figure. How many smaller cubes will be cut here? Okay, so we are given here a cube and the cube is getting cut by this particular plane at the points A, B, and C. We have to identify by the plane how many cubes, smaller cubes are getting cut in the larger cube. So evidently, let's just first count the cubes that are definitely getting cut. So we have 1, 2, 3, 4, 5. And then here at the back, like you have 4, there will be a 6th cube also, which will get cut. Now, besides these which are given here, there will also be this cube that gets cut diagonally. So this will be your 7th cube. Select the 7th cube, there will be also the 8th cube which will get a cut because it's the same situation. And also besides this, there will be also this cube which will be getting cut partly by just a part here, which will be your 9th cube. So total 9 cube will get cut by the plane that is formed here. Okay. We'll now move to the next one. X1 is a 3D form generated from the shape X using a certain 3D operation. So we do some 3D operation on this pattern X and it generates this kind of a 3D. This particular 3D has 14 surfaces. Okay, how 14? 1. So this is 1, 2, and 3. 1, 2, and 3. Sorry, not that way. So there are 14 surfaces as 1 and 2. These two surfaces getting repeated 1, 2, 3, and 4 times. So 8 surfaces here plus continuous surfaces are this and this. So 2 such continuous surfaces moving one to the other end here and then another end here. So 4 such continuous surfaces. But sorry, not 4, but 1 and 2. And then bottom also 3 and 4. But then if you see it's a continuous surface, there's a junction getting formed. So actually it will be just 2 surfaces. Okay, here getting formed, we have 2 surfaces. Why? Because this is one continuous surface like this across and then the same cross happens at the bottom. And then plus besides that we have 4 more surfaces which are the plan, the base of it. That accounts to 14 surfaces. Okay. Now, If this particular same 3D operation is performed on the shape Y, we have to count the total number of surfaces that gets generated in the 3D. Okay, so let's see the shape Y now. So in the shape Y, when I repeat that same process, this is the kind of 3D that gets generated. In this, if you see this particular surfaces 1 and 2, 3 and 4. So these two surfaces are same. They will actually generate, so this are the 1 and 2 and then 3 and 4 at the back. They will generate 1, 2, 3 and 4 surfaces. Okay. Plus the curvature will be 2 more surfaces added, that is 6. Okay. Now we look at the other part. So that completes this part, the curvature wala part that gets completed. Now we look at the opposite ends, these two. In this particular one, the bottom surface, if you observe, is one continuous plane. So it is making 1, 2 surfaces plus the outer surface, they are getting divided by these corner junctions. Okay. So they will generate 1, 2, 3 and 4 surfaces. So that will be 6. Additionally, besides this, what we have already counted, there will be certain surfaces that gets left around, which are the base. The base has 1, 2, 3 and 4 faces, so 4. So addition of both of them, of all of them, 6 plus 6 plus 4 will be 16 total surfaces made in the 3D. Okay, we'll now move to the next one. If the given shape in the figure is used to tile a grid on the right without any overlaps, what is the minimum number of units that will be left uncovered? You can flip and you can rotate. Okay, we have to identify the tiles that will remain uncovered. Okay, so how we will tile it. So let's look at it. So first tile, we start with this kind of an orientation. Oh, sorry. This kind of an orientation. Okay, 1 and second. Next, we tile it here. Once again. Okay, yeah. And we tile it here. Sorry, here. Okay, so that completes our 4 shapes. Next, we tile it on the corners. So, yahan pe I will tile it here like this. Here, I will tile it like this. Here, I will tile it like this. And on this facade, I will tile it in this manner. So after tiling it in this way, I will be left out with 1, 2, 3 and 4 such tiles which are left empty. So answer is 4 tiles. Okay. We'll move to the next one. So this is how the tiling will be happening. Okay. Leaving out this 1, 2, 3 and 4 tiles. Okay. Yeah. How many distinct motifs appear in the figure on the right? Flips and rotation, you have to count it separately. For example, we know that Q is rotated version of P, but they both have to be counted as distinct motifs. Okay, different ones. So these are all the 8 distinct motifs that occur in the overall pattern. All other motifs that you see at the back are repeated. Okay, we'll move to the next one. A sphere, a cylinder, and a cone with equal heights are resting on a surface along a straight line. If the source of light is fixed and the light rays are parallel, which of the option shows the shadow correctly? Okay, this is what is being asked. So, in this case, let's look at the pattern that gets generated. So here, if you see, look at the shadow that gets generated. Now here, if you see, if I draw a line, the line of the shadow, in this case, second, yeah, if I draw the line of the shadow for the cone, it will be so big. For the sphere also, the length of the shadow will be so much. And for the length of the cylinder, it will be so much. If you observe in option A, all the lines are of similar length, okay? Option B, let's see it. One here, one so big. And with reference to the cylinder, it will be so much. With case of option C, it will be the length of the shadow will be equal. Now, why am I drawing the length of the shadow here and compared to the points that are there is because I have to first identify the height of the object. The length of the shadow is a resultant of the height of the object at the end of the day. Okay. So, if I see the shadow length, if the shadow length is the same, what it means is that the height of the object is the same. And that's what is given to us, that all three objects, sphere, cone, and cylinder, are of equal heights. So in the option where the heights where the length of the shadow is equal, the height has to be the same. Like in case of option A, the red line is almost similar. Okay. The angle light might have differed. Like at this one, I might have drawn a little bit bigger, but yeah, it's similar. So A is correct. In option A, all the heights are same. Versus if you observe option B, this line of the cone and the cylinder are bigger versus that of the cone and the sphere are bigger versus that of the cylinder is small. In B, therefore, the cylinder is short. Okay. Now, if you observe option C also, the red line is of similar height, similar length, which means the height of all three objects in C is also same. So C is fine. The shadow is correct. Versus in case of option D, it's like how B used to do, where the cylinder is short because the length of the shadow is shorter. So D is wrong. So the correct answer is A and C. Both are correct here. Okay. We'll move to the next one. We are given here two similar images. You have to count the total number of differences that are there between the two images. We have to count here the total number of differences that are there, right? So these are all the differences that are there between the two images. So this is the first one, second, which is a straw missing, third, which is the color of the chutney, fourth, missing bowl, fifth, the spoon is missing, sixth, color of the bill, and seven is that wooden piece which is wrong of the chair at the back. So correct answer is 7 here. We'll move to the next one. 5 friends, Puru, Kadir, Roy, Sham, and Tom, they live on the 5 vertices of a regular pentagonal round in a clockwise order. Order is same. Puru, Kadir, Roy, Sham, and Tom. One day, while Puru was walking to meet Roy, he met Kadir, who was on the way to meet Tom. Kadir changed his mind and decided to go with Puru to meet Roy. After meeting Roy, all three went to Tom's house for a cup of tea. If all of them took the shortest route, cutting through the ground, which of the following statements is or are true? One or more options is correct here. All right. Let's first draw the diagram in this case. So the diagram will be like this. We drew it in order along the pentagonal ground. So Puru, Kadir, Roy, Sham, and Tom. That's the order which is given to us. So what happens here is Puru is on his way to meet Roy. He meets Kadir at one junction. So far, Kadir and Puru, they travel the same distance. So far, Puru and Kadir, they are traveling the same distance if you observe that black line. From that, Kadir, who was on his way to meet Tom, changes his mind and goes to Roy's place here. Which means, again, Puru and Kadir, they are traveling the same distance and they meet Roy here. After that, they all go to meet Tom. Okay? Here, which is shown by the green line. Now, let's look at the option. Till Tom's place, Kadir walked more distance than Puru. And option B says till Tom's place, Puru walked more distance than Kadir. Actually, if you see till Tom's place, actually Puru and Kadir both actually are traveling the same distance. This distance, like we saw earlier, this one is the same. This segment is same they took together, and then this is again same that they took together. So A and D, B both are wrong here because it is equal distance and not more or less. Now, see, till Tom's place, Kadir walked double than the distance of Roy. Yes, Kadir is taking one segment, second segment, and the third segment versus Roy is taking just one segment. So C is correct. While returning to their respective homes, from Tom's place, Puru has to travel the least. Yes, because Puru and Tom are neighbors, the least distance will be taken by Puru. So D is also correct. So correct answer is C and D both. We'll move to the next one. Which of the following statement would you consider to be true about the hour and minute hand of analogous clocks? Okay, we have to consider this with reference to analogous clocks. One or more options are correct here. So option A says the hour and minute hand would make 90-degree angle with each other 24 times in a day. Okay. So 90-degree angle is being made every 12 hours. 90-degree angle is made 22 times in 12 hours, which means in 24 hours, it will be made 44 times. So option A is wrong. Next, the hour and minute hand will overlap less than 24 times in a day. Yes, that is true because in 12 hours again, overlap happens of hour and minute hand happens 11 times in 12 hours. So in 24 hours, it will happen 22 times, which means it is less than 24. So B is correct. Next, the hour and minute hand will overlap exactly on the hour number marker only once every half a day. So hour number marker is 12. They will overlap at that particular point only once every half a day. Half a day is 12 hours. So they will come back to that original position at 12 o'clock, which is true. So that is correct. D says hour and minute hand will make acute angle to each other for almost as long as they make obtuse angle. Yes, that is also correct. So correct answer is B, C and D. All three are correct here. Okay, we'll move to the next one. So yeah, this is what is it? The same thing. 12 hours they make 22 times. So 24 hours they make right angle 44 times. And these are all the times that they coincide. The hour and minute hand coincide in 12 hours. Okay, there are 11 times. We'll move to the next one. An illustration of an ant walking an illustration of a walking ant and a pair of glasses are lying on a table is shown. What is the correct illustration from the ant's point of view, current point of view? So if you look at the ant's point of view, it is almost in alignment with the stick of the spectacles, which means that it will see the spectacle but very minimally, like we see in option A and D. By that itself, B is wrong and C is also wrong. Now, if you compare A and D, they look similar, but they're actually quite different. If you see the handle of the stick, it comes down further from the base here. Ideally, if the stick is farther away, it has to be a position. It has to be slightly lifted up like we see in option A and not how we see in option D. So D is wrong. Option A is the right answer here. Okay. With this, I will end today's session here. Thank you so much for your time.